Okay. Hello, everyone. A hearty welcome to all of you here. Hope you're all safe and taking care of yourself. GDG and WTM Kolkata is back with amazing session with one of the most emerging technologies with exponential industry growth. I think this is the first time we are organizing this kind of session. We have some amazing speaker with us today. Avi Dwivedi, the founder of Extended Reality Developers of India, aka XRDI, will be giving the XRGenesis workshop for GDG and WTM Kolkata. Over to you, Avi.
Thanks, Ria. Thanks for such an amazing introduction. Okay, so yeah, we shall begin. Let me start showing my slides and we'll go over it. Okay, so let me know
Yes,
whenever
over
you
to
are
you.
ready. Okay.
Yes.
So can I show my slides now? Yeah. Okay. Amazing. Okay. So hi guys. Hope you are doing great. Hope you're having. Hope you're fine in this crisis and doing well. So let's start with the talk. We are doing this XRGenesis. So XRGenesis means the very beginning of XR and how everything comes to picture. Okay. So let's talk about. First of all, me. Okay, so what I do, who I am. So I am Avi Dwivedi, and I'm the founder of Extended Reality Developers of India, also known as XRDI. So XRDI is basically the community of XR, and it is luckily the biggest community of XR in India. We have 3,000 plus members right now, and they are growing day by day. Okay, so let's also talk about the other things apart from this. So I have served as a medical imaging scientist at Immersive Touch, as well as I'm running my own company, which is Utile Studios, which handles all sort of AR, VR, MR, 360 work. Okay, so now moving on, we are going to talk about XR industry introduction. Okay, so absolutely, XR industry is a huge industry and the most emerging industry, and we are going to talk about how you can get into it and what is XR exactly. Okay, feel free to drop any kind of comments if you have in the comment section, and we'll be able to answer. I'll be able to see and comment on that. So let's start with the next slide. Okay, so there are technologies called VR, AR, MR, XR, and they're also called CR and LR. Okay, these are all sort of technologies. There are so many R's there, so let's understand them. Okay, so VR means virtual reality, augmented reality, mixed reality. CR means cinematic realities, and so on. Okay, so what are they? So you might be familiar of AI, and AI is an umbrella term for all the technologies like machine learning, deep learning, convolution, neural networks, and all those technologies, right? Similarly, XR is the umbrella term for these all realities so far. Okay, haptic technologies, VR, AR, MR, CR, whatever. So XR is basically the binding term of all these technologies. So let's break it down that what is digital, what is XR exactly. Okay, so the very ground, the very initial of XR, you can say it's digital. Okay, any content is digital. Let's understand digital. So digital is any information. If you represent that information in form of binary digits, so that's called digital. Any information, you can represent any information in form of binary digits, and that's called digital. Whatever is not physical, you can call it digital. Okay, now there is a similar term which is called virtual. What is virtual? Okay, so virtual is similar to digital. It's almost the same term as digital, but different in a very different with a very small unit. So what is that difference between digital and virtual, and why we have those two terms, and they are explaining the same thing, that anything which is not physical. So turns out digital is used for the communication between a machine and a machine. okay, or a machine to itself like programs. So when digital is not meant to be understood by humans, so whatever is not meant to be understood by humans in and constructed with binary digits, which is not a very good way for humans to communicate. We don't say 100 110 means hello or something like that. We simply say hello. So virtual is the digital form of content, but it is meant to be understood for humans. So for example, you are right now seeing these slides, you are seeing me, and all this form of content is virtual content, okay? Because these are made for you to understand. Uh, for sure, these are made with the digital bits, but these are virtual content. So this is the very definition of virtual. You can also call virtual as visually digital because that's what it is. Okay. So now what are virtual simulations? So let's understand these terms. So there are a lot of physical phenomena in this physical world, but we can replicate the very same thing, the very same physical phenomena in the virtual world with the virtual bits and bytes. Okay, once when we do that, we call these property, these behaviors as virtual simulations. For example, you see a train running, and if you craft that train running in form of a cartoon, so that is a virtual simulation of that physical phenomena. Okay, now what is virtual reality? Now imagine if I make a world, a virtual world, and put a human in it, a human consciousness in it, and basically hack all the senses of the human. Understand it this way: I put you in a virtual environment, and you are able to hear all the sounds of that virtual environment, and you are able to see virtual environment everywhere around you, and you are able to feel it, touch it, smell it, and interact in every ways with it. Okay, so such condition is called virtual reality. Okay, and also there is one more term which is related to virtual reality, which is called immersion. Immersion basically means when once you are in virtual reality, you should not be able to feel the world outside. Means you should be completely immersed in the virtual reality. There is also one term known as AR, augmented reality. So what is augmented reality? Augmented reality is basically the very opposite of virtual reality. On one hand, we are trying to bring you inside the virtual world in virtual reality, and now we are trying to get the in augmented reality, we are trying to get out the virtual objects from these virtual worlds in the real world. Okay, so these are completely opposite. There is also called MR, yeah, mixed reality. So mixed reality is basically the extended version of augmented reality. You can say they are very similar. The only difference is the display on which the content is being presented is mounted to your heads. Means it could be eyeglasses, it could be a headset or whatever. Okay, so when you see through the headset, the content displayed on the real world and interacting with the real world, such content is mixed reality. So also there are technologies like virtual haptics. So virtual haptics is a technology which allows you to feel objects or touch objects which are not actually there. For example, in once you go in virtual reality, you are not able to, you are able to throw your punches out of the wall, the virtual wall, because they don't exist in the real world, and your punch exists in the real world, right? Okay, so in with the help of virtual reality, we uh, try to prohibit you from doing that. We try to stop your punches before they hit to the wall. There are a lot of techniques, there are a lot of robotics involved in this virtual haptics, and we'll look into it in further slides. Okay, spatial audio, there is spatial audio has been there for a lot times. Even every A.R. Rahman song is a form of spatial audio because it surrounds is something called surround sound, which means once you hear the sound, you should be able to tell that from which location that the sound is being produced. Okay, so since we have 2 ears, once we tell you that from which location the sound is coming from you, your brain calculates it, that how much sound is coming from the left ear, how much sound is coming from the right ear, and based on that the calculation happens in your brain, and then you say, okay, sound is coming from that direction. Okay, so that kind of sound is called spatial audio. Now there is something called location based XR. So location-based XR, if you have heard of Pokemon Go, so Pokemon unlocks only when you reach at a certain location. The content is bind to that geographic area. Okay, so such AR, such augmented reality experience is called location-based SR, and it's a big market of that. Okay, so now we have understood all the types of augmented XR. What kind of what are all the types of XRs? Okay, so let's talk about business, because without talking our numbers, there's no sense. Okay, so numbers are pretty amazing, and the source is BBC Blogger report. So in 2018, this is the investment number into the virtual reality and virtual reality production and virtual reality research. Okay, so these numbers are fascinating. These numbers are $21 billion in 2018, and these are growing at an exponential levels. So in 2019, you will see a rise, a hike of $11 billion, and it become 32. So on. In 2020, it is right now $51 billion, and it's expected to be by 2025. It's expected to be as huge as $394 billion. Now, who will own, and how? What will be the distribution of this $394 billion by the year of 2025? Here is the answer. So these are all the companies who have invested in virtual reality. So now the question is, every company which you can imagine in digital technologies is investing in virtual reality. So why you think, this is going to be the distribution of virtual reality earnings, right? So every company is there. Facebook is there, Sega is there, there is YouTube, there is you can say Sony is there. Each big company is already see the growth of virtual reality, can see the potential of virtual reality, and investing in virtual reality in some one way or the other. Okay, now I have a question for you guys. If you can type that in the comments. So I have a question for you guys, which I'm sending you. I'm going to tell you that in what is your virtual reality idea? If I tell you to make a game, experience, application, so what kind of content you will produce for virtual reality or augmented reality or mixed reality? Okay, so write down your comments. Okay, and let me come to the answer of this particular question. So what kind of content you can produce for virtual reality? Answer is this. So you can see games in virtual reality, which are actually the 75% of virtual reality. You can see entertainment. Entertainment means all sort of songs, videos, movies, right? Movies are being produced. People are dancing. People are enhancing their dancing skills and mixing them with the skills of AR and virtual reality. I showcase some of the videos. Art is being mixed and merged with virtual reality and being used exponentially in form of tilt brush applications and all. So I know someone who is a public figure because of using his art skills in virtual reality. She came to India and she performed one concert for Vive. I'll definitely interview her someday on my podcast channel. So I'll let you know, guys, when I do. Okay. Social interactions, scientific simulation, trainings, military trainings, education, space programs, business presentation, marketing, healthcare. Now, my question to you is that why almost everything you can imagine about virtual reality is there? Okay. So why? The answer is very simple. You need to understand this. Virtual reality is a medium. Okay, it's not just a technology, it's a medium. What happens when something is a medium, and why medium is bigger than technology? Because understand another medium, television. Television is a medium. Television is a medium, and what kind of content you can produce for television? Answer is everything. You can produce dance, drama, television, reality shows, cookery show. You can have Sanjeev Kapoor cooking meal on television. Okay, so you can literally produce everything for television. Virtual reality is just that, television and much more. So you have to assume virtual reality as the next television. Okay, so any kind of content, no matter whatever kind of art or craft you have, you can reproduce that using virtual reality, augmented reality, and we'll help you doing that. Okay, so now see this experience. This is one of my favorite and close to my heart, because virtual reality is being used in this way even. Okay, uh, do we have connection problem? I don't think so. Okay, let me just check how fast I am going. Yeah, connection seems fine. Okay, no issues. No issues with the connections. So let me just replay this slide. I'm going to hold on. Okay, I can also. Okay, yeah, it's working. Okay, so you can see in this slide, there's a 7-year-old deceased girl, and her mom decided to bring her back using virtual reality so that she can spend some more time with her. So she can touch her with these gloves. These are haptic gloves. I told you that with the haptic technology, you should be able to touch the virtual object. So she's not just the virtual object, she is her daughter, which is bring back using virtual reality so that she can spend some more time, maybe celebrate one more birthday of her. So this is very emotional. This happened in Korea, and her mom bring her daughter back. Okay, so now we saw this demo. Now I have one more demo if you want to saw. So you can scan this image on your mobile devices. So you should be able to scan it on your mobile. Okay, so let me know when once you do it and what you see. So take picture of this and scan this on your mobile devices. Let me know what you see. So you should have, if you have an iPhone, it has a built-in scanner. If you don't have an iPhone, if you have make sure you have the QR code scanner. Even if you don't have the QR code scanner, try using this link, unitilestudios.com/AR test. So I'm dropping this link in your comment section. Okay, so you should be able to try this AR experience. And this is a kind of a small office, you can say. This is some sort of small office. Let me show you to those people who are watching this live on XRDI. They should be able to see my whole screen, so they should be able to see this link working. Okay. So let me open that. Let's come to another scene. So this is the haptic glove from Tesla suit looks like. This is one of the company which is working on the full body haptic technology. What is full body haptics means? If somebody shoot you in virtual reality, you will feel some kind of punch. You feel the punches. You will feel the arrows, bows, all those hits on your chest, on your legs, on your full body. Okay, and you should also be able to touch things, feel things. So this is a very fascinating technology on which the companies are working on. So now let's talk about what we are doing in virtual reality. So we are Extended Reality Developers of India, also known as XRDI. We are the biggest community of XR. So we are working on XR awareness. We are telling everyone that, dude, there's something called virtual reality. We are doing that by doing these kind of sessions with each and every webinars, and also going to the colleges, and we are doing such sessions with all the students. So also we are producing content. We have 13 plus collaborations running right now with major studios, including Reliance. So we are doing a lot of promotional content and a lot of content for XR. So for XR entertainment, we are doing a lot of stuff. We are working on a movie which is going to be released in the 360 mode. So imagine a movie where you can see everywhere, everything. You see on a 2D screen, you see only this part of the window when you go to see a movie. But what if you can be there? What if you can look around and see what other characters are doing? What are the other actors doing? Okay, so you can see everything in 360 movies. So we are producing that. And skill democratization, we teach you how to sharp your skill with virtual reality. We try to guide people using this thought that any kind of skill could be transformed and merged with virtual reality and augmented reality, and they can enhance the value of their skills, the value of their 1 hour. Okay, so they can do that. Also, we are doing a tremendous kind of virtual reality networking, XR networking on our group. I'll show you the link and you will be able to join that. It's completely free. It's not, there are a lot of groups which are paid. And by paid, I mean heavily paid. Okay, so but our group is totally free for everyone, and they provide all kind of facilities which other group provide. There's one group. I must not talk about that. So this is how you connect with me. This is facebook.com/XRDI India. This is our Facebook page on which you can go and like. If you need to ask any questions, please feel free on asking on the live. If you want to ask any kind of questions on later, so drop them on my mail, which is here. Okay. So also there is XRDI's mail, my mail, so you can definitely connect with us. These are some kind of courses which we provide. We'll provide you the slides here, and we'll provide you these slides. Click on this link and you will be able to see these courses. These courses are complete. These courses are completely free from our side, and these are equivalent to 3 years of experience in virtual reality or game development. So you can definitely try that. Okay, so if you have any questions, because we are going to move to another session which is more technical in nature than this. This is sort of introductory. The second session, which is computational thinking for XR, is going to be started from now. Okay, so yeah, I am getting no comments or I'm getting no responses here right now, but I hope you guys are seeing this. Okay, no issues. Let me move to the second session. If you have any questions, so I'm available for Q&A. Okay, let me share my other screen on this, which is the other. Okay, how do I share next screen? Okay, stop screen sharing, start screen sharing. Okay, share screen. Okay, share screen. Chrome tab. Okay, so I'm going to do the computational thinking now. Okay, now you should be able to see the computational thinking tab on this. Yeah. Okay. Awesome. Okay. Now you are able to see. No issues. Yeah, we are starting computational thinking, which is the second part of this session. So what happens? XR has become very easy for anyone to do right now because of all the technology improvement, because of all the new thanks to all the new technologies like Unity and Unreal coming into the place and making this easy for everyone. But like you cannot learn how to make a game by pressing the play button of Unity, or you cannot know how to make AI application by using some pip install. You need to know a lot of concepts behind how the things works. So this computational thinking is required for that session. Okay, so I have a question to you guys. What is this? Okay, what is this on this screen? So some of the people will say this is 1, 2, 3, and some of the people will say this is 123. So my question to those people who are saying this is 123 is that you must be doing this calculation in your head. Okay, so you must be doing, you must be making sense of this 123 by understanding this process. Okay, so the process is, this is the first place, this is the 10th place, and this is the 100th place. Okay, so which means, which you can also write it down like this: 10 to the power 0, 10 to the power 1, and 10 to the power 2. Okay, so this is, you must be doing this calculation in your head: 1 times 3, 10 times 2, and 100 times 1. And then you add them and it becomes 123. We do it in every day of our life and it becomes very natural to us. And that's called decimal number system. We have grown up with this number system. But there are other number systems which are very important. For hexadecimal is there, and there are binary. So binary is surprisingly the most important. The reason is that every machine you have is using binary number system to communicate with each other. Like I also told you, this is the digital communication, which is the binary communication 0 and 1. First of all, why do we use binary and why don't we use a normal number system? Why we are making things so hard for even us to understand? If terminators are going to attack us, we are not going to able to decode their languages. But why we are doing that? Okay, the answer is, binary is very easy to to sustain, to maintain as a state. Okay, think about it this way: binary is just a switch. You either it can be on or it can be off. Okay, but with decimal number system, you need a regulator, not a switch, like you have in a fan, which maintains 5 to 6 states. So small, medium turn, then faster, then faster, then faster, up to 6 levels. So to maintain this 6 levels, it's not possible to maintain this 6 levels with lower sizes. For example, if we need to make information stored in this size of devices, like pen drives, it has to be very small in terms of scale. We have to go very small. In fact, we are going right now at the quantum levels. And apart from that, we cannot, right now, a single bit has a physical size of almost 1 to 2 atoms. So it's that far. In fact, they are stored in form of atom now. Okay, so which actually means if we go beyond that, we will hit the quantum phenomena, which actually means we will hit things like quantum tunneling and quantum entanglement, which will not allow us to use traditional computers anymore, which will not allow us, that will break down, so that we are also inventing traditional quantum computers. But that's not the topic. Topic is this binary. Okay, so this number is 4. This is 4 written in binary. Let's understand it. So fourth bit is on. The bit which represent the number 4 is on. How do we represent number 5? Answer is, we turn 4 on and we turn 5 on. Now it's representing 5. How do we represent 7? And this is the maximum these 3 digits can represent. Okay, how do I represent 6? So I turn off this. Now it's representing 6. Okay, 4 plus 2, and 1 represents, 1 bit is 0, so that's not the count. Now, since we can represent numbers, but numbers are not the only thing we need to represent in binary. Numbers are not the only thing we need to communicate. So how do we communicate in letters? I need to write a letter, not a list of numbers to someone, right? So turns out, to do that, we have only one way. We have to agree with some sort of map. This map is called ASCII, and this map existed for years, like very years. Okay, so for on this map, the location of character A is 65. So we can definitely convert the number 65 into binary. Okay, which means the A is mapped to this number. So now we know how to convert numbers, but still there's a problem. A has a shape and numbers have no shape. So how to represent this? Okay, so it turns out the fonts, how does font work? Font is basically the shape created by character artists. So you have seen a lot of fonts like stylish F and all those, Arial and all those stupid fonts. Okay, so you can basically have any number of fonts, and the number of the location of that font is 65. So in the different font, there will be a different image picked from that font and will be used. Okay, so that's how font works, that's how language, that's how character works. If you are sending someone a message like this, hi, so exactly the information which is being sent to them is this 72, 73, and 33. So no, of course there are going to be a lot of compressions. Of course, there's going to be a lot of packaging of this data, but it always boils down to these numbers. Okay. Now let's talk about smileys. So like I told you about font, smileys are exactly that. You have some numbers and you map those numbers to font. Let's also talk about this. Why is smiley? What are colors? So colors are basically three values. So with three values, you can represent any sort of color. So what are these values? You need some value for red, you need some value for green, you need some value for blue. Okay, and also you can also represent the color scheme in HSV, which is hue, saturation, and value. Okay, so these are these are two ways for representing the colors. Now, fun question: why the question? Why the color of this smiley is yellow? So we have seen a lot of yellow smileys in our comment section. If you type a comment, you'll see we have a lot of smileys right now. So why, my question is, why the smiley has a yellow color? Answer is very easy. 72, 73, and 33. When you send, hi is the mostly sent message. So when you send a hi, these numbers are being sent, and if you convert these numbers into a color scheme, it will become exactly this yellow color which you use to send to each other. Okay, this is a fun fact for sure. Okay, now let's talk about other smileys like this. So these has a higher number on the number scheme. This is for A represent 65 number, but these poop represent 128 and 169 such numbers. Okay, so these are later part of, and there are a lot of languages. Each language has a different map assigned to that particular character. Chinese has a lot of characters. Okay, so now let's come to images. We understand what is color, so now we can come to images. So images are nothing but bunch of colors stacked up in form of a grid. Okay, you can see. So each color has a value, and value is being slightly differentiated and to the other color, and you can see that's how the transition of image is happening. So also there is a whole science of breaking down that what is visible in the image based on its color values, RBGs. So for example, we can definitely see an edge here using computer vision algorithm, because that's what they do. They use a technique called convolutions, and they form the kernel and process the image neighboring colors, that how the transaction is happening. Okay, but that's the part of another. Let's watch this video. It's a cat, it's a beautiful cat. Okay, so what is a video but? Okay, video is nothing but the sequence of images. So these sequences of images are slightly different to each other, and they are stacked such that they make some sense. So right now they are 30 FPS, which means they have stacked 30 images in 1 second. If you move these stack of images one at a time, such that you move 30 images in one second, so then you will make sense of these images. So FPS means 30 images per second. For virtual reality, you need 90 plus FPS, which means you will going to change the images at 190 of a second, which is a very small value. Okay, now let's talk about what is an algorithm at the first place. So computers work because of algorithms, but what are algorithms? So you can imagine algorithm as a black box. Now here is some input and here is some output, and output is being mapped to input. Okay, so and also there's this whole science of understanding how the input is mapped to output. That's called deep learning. Okay, so that's what it does. It tries to understand the mapping between input and output. Hmm? So let's talk about one algorithm, which is my favorite example for some reason. If I have to search a number of a person called Srinivas, okay, so how do I search it in a directory or a telephone directory? Okay? So we have two methods of doing that. One is you can take the directory, open first page, read all the names, not find it, second page, third page, fourth page, and eventually you will reach Srinivas at some point, right? And is this method a correct method? Answer is yes, it is a correct method. You will be able to find Srinivas. Is this efficient? Answer is no, it's obviously not efficient. It will take a lot of time. So how do we find Srinivas? So let's talk about another scenario where you take the dictionary, you take the directory and you rip it apart half, just half. So in one hand you have M, or in other hand you have N pages. So Srinivas can definitely not be A to M pages. You throw away these M pages and take the N pages. So now you again rip apart the dictionary in half. Now what you have? You in one hand you have all the S pages. In the other hand you have all the T pages. Srinivas can never be in the T pages, T to Z. So you throw that, and now start reading the S pages, and then you will find the Srinivas. And this is an actual algorithm called binary search. Okay, even the first one was an actual algorithm called bubble search. So let's the second algorithm is definitely a correct algorithm because you will be eventually able to find the Srinivas contact, but also much more faster. For example, the complexity of bubble sort is O(n) squared, which means you are going to it's going to take a lot of time. On the other hand, the bubble sort, the binary search is going has a complexity of O log n, which means it's an exponentially fast algorithm. How much time it will more take if you add a similar amount of number of pages? If you double the page, how much time it will take? It will take one more step only. So it's very fast. Now let's talk about what is 3D. So there's no such thing as 3D because eventually everything is constructed from binary, but let's understand it. If I have any object, I have this iPad. So if I have this iPad and if I try to make a 3D model of it, so I can make that, I can count the edges. There are 4 edges, 1, 2, 3, 4. Okay, and I can mark all my edges at a position relative to each other. So this is 0, 0, 0. This is 0, 1, 0, and so on. We mark each edge. We provide each edge a location which is in 3 dimensions, that how far in width it has, how far in height it has, and how far in breadth it has. So we can definitely do that. Okay, and once we're done doing that, we have a box kind of shape. Okay, so then we can when we have algorithms in such a way, which is called graphic pipeline, and the graphic science is the science of generating 2D images from any kind of data. So if you have any kind of data and you want some graphic images, some images to be generated, that science is called graphic science. Let's understand the graphic for a bit. So first we have the vertex processor. So it basically process each and every value which are being generated by you using these numbers. You have added some numbers, so it's going to process which numbers is first, which numbers is going to become later, based on from which rendering point you are going to render this. So it's going to output an image, but on the image, this object, where does it stand and how big it should be rendered. So the first process is vertex processing. Then it comes to rasterizer. So rasterizer has only one job, and that is how many pixels are going to be affected by this. how many pixels are going to be affected by this particular shape. It basically marks all pixels, okay, of that output image. Now comes the fragment processor. So fragment processors, input of that is the amount of pixels. So affected pixels are basically put it in as in the fragment processor as input, and the output is going to be the color values. So based on what texture I want to add on my on my object, there is something called UV coordinates, basically the U and V's, which means the two-dimensional values of mapping of texture. So that texture is mapped to this object in the fragment processor section. So now my pixels has color, and finally I have the complete image rendered. I can display it on any kind of screen. So that's how you create 3D images. But hold on, we have 2D screen, 2D images. What is 3D then? Where is the depth? Okay, so we'll try to answer that in the next slide. But you might notice that is a lot of value even creating a single cube. We have to deal with a lot of values. A lot of value is there if we want to create a single object. For each point, we are adding 3 points, and there are eight or more vertices. Actually, in a cube, we have 24 vertices. We count. Okay. But so it's definitely going to be very hard to create objects, but we do create objects using the help of these tools. These are Max, Maya, Blender. All these are basically the graphic creation tools. These are artistic tools, and an artist they don't require any kind of code. Means an artist could use concepts like symmetry. An artist could use concepts like molding. So like you mold clay models. In real life, you can also mold these graphics, and the algorithms behind this handle that artistic performances, and you can create graphics like this. Okay. Now these kind of graphics are being fed into the rendering engines, which are Unity, which are let me come to that slide. Okay, for some reason it refreshed. Okay, now these graphics are the output from these engines. These output are in form of files like FBX, Maya, Max. These are all the output files. Okay. So now we put these files in the graphic engines like WebGL, Unity, Unreal, Buildbox, all these graphic engines. And now these graphic engines generate something called they render, they perform physics, and they generate images like these. So after performing the rendering pipeline is there, what I explained. Okay, so still the output image from these software, these graphic engines, is basically a 2D image. So still we don't have reached 3D. So where is the depth? How do we reach 3D? How do we reach 3D? Where is the depth? Okay. So to answer this question, let's come here. So we figured it out in 1838 that if we send different images to different eye, okay, if we send a left eye left image, a right eye a right perspective image, if you send different images to your eye, you are going to see things in 3D. And this is why you see things in 3D, because your left eye and right eye has a different offset, and you see from a different perspective from both eyes. So your brain basically does that calculation that how offset is that and how far the things should be. And you see 3D in your brain, not in your eyes. You can also say that. Okay. So based on that, this product was built in 1838, and so far we have made a lot of progress. I talk about this is Sensorama. This is an incredible machine. This used to have, I'll answer all the comments, I'll see once. Okay, this is Sensorama. This machine has incredible capabilities. You can feel the wind, you can smell the sensations, and there was vibration, there was a lot of things. This is something built for army pilots specifically. This is called This is called Super Cockpit. So Super Cockpit, you can see such heavy headset is. And now this is the today's headset. This is 2016's Oculus Rift, but today's headset is a more Oculus Quest, which came in 2019, and state of the art machine in virtual reality. If you want to buy one. Okay, so I showed you a lot of demos, and yeah, I think this is all. We have covered everything, and here is how you contact me. And if you want to join our community, just scan this code and come to us, and we'll take care of the rest. Okay, so this is basically you can scan this, and we will be able to connect with you, okay, on XRDI community. So for sure, the session is over, and let me know if you have any questions. So I'm open for Q&A. I'm going to read some of your comments. So Blender is professionals' favorite. Yes, Blender is, but there
I
are some
agree.
limitations to Blender. But so they also use Max and Maya. Okay, Blender is definitely professionals' favorite. But for what kind of task you want to do, and how performant it's going to be, based on that you select your tool. Can you share some minimum computing power needed to work in AR VR content? Okay, so definitely you need a lot of processing power for computing VR AR images, because I told you there's something called rendering, which generates 2D images from the 3D images. And why VR and AR are expensive? Because you have to generate two images, each for each eye you need to generate image. Okay. Somebody asked me, so obviously that is expensive. Somebody asked me that what are your views on movie upload, which is available on movie upload, which is available on Amazon Prime. So I have not seen the movie upload, but I have seen similar movies. I'm not sure what is it about. Okay, I got it. I watched the trailer. Yes. Okay. So a movie upload I have not seen, but similar things I have seen. So Netflix has a similar Black Mirror episodes. So yeah, that's amazing, and that is something which is possible in the future for sure, because we are able to see what is in the brain. Okay, there is a technology called fMRI, which is functional magnetic resonance imaging, which means we are able to see what you are thinking. We can make a picture of that, of your thoughts, of your dreams. So this is possible. We are so someday it will also be possible to scan the consciousness out of your brain. So yeah, this is a very amazing series, and you must watch it. On the Netflix, Black Mirror has a lot of episodes which are similar to this. Yeah, I got your point. Yeah. Okay. Actually, I made AR apps on biology. The concept was when you read a book, it gets boring. Okay, amazing. A lot of people are making a lot of cool AR experiences, and uh, the benchmark of reaching the AR is very easy. I mean, you don't need any kind of expensive hardware, so it's very easy to start with AR. Definitely do start with AR. Okay, and somebody said good afternoon, so hi, good afternoon. What kind of content would you like to produce in MR, VR, AR? So yeah, you can produce any kind of content, whatever you resonate with. You can produce a movie. You can produce any kind of content. I mean, if you dance, you can showcase your dancing skills with the help of AR. So there are a lot of people who are showing some kind of dancing skill with AR and all. Okay. And I'll keep sharing such kind of skills on my community, so you can scan this code and reach to that, and GDG is helping me doing that. So thank you really much to every one of you for organizing this. So I think, yeah, Ready Player One is also a marvelous movie regarding VR. Ready Player One was a book, and in the book, the very description of virtual reality world was amazing. So the book version is much better of virtual reality one, and the movie was directed by Steven Spielberg, and it definitely did a great job in that scenario. So yeah, can you suggest good quality materials or courses? Yeah, come to XRDI. We are producing our courses. We are creating the material. Also, I did two sessions. One was called XRDI Dive Guide, which covered the whole complete history of VR, which was more oriented on VR. Also, one more VR session where I covered the ethics of VR. For example, once you put, you cannot punch someone, right? You cannot punch someone. But when you put someone in this headset, you also should care about what he's going to see and what is going to be the psychological effect on these headsets. Okay, so you have to be responsible of that, and what are the ethics of showing someone some you cannot scare the shit out of someone by throwing them from buildings, but that's what people do. And there's something called Archie's plank, and people are throwing each other from the buildings in VR, which is horrible. So don't do that. So I covered the VR ethics, that what are the best ways of and how to tackle with the motion sickness of VR and so on. So yeah, definitely these sessions are amazing to check out. Go read book then. Got to read book then. Yeah, you can definitely read the book. Ready Player One is also a very good implementation of that book. But yes, I prefer the book. Okay. Yeah, I think this is all. I think I covered all the questions, and you have unlimited time of asking questions on the XRDI's page. So you scan the code, and you will be able to join the community. We will talk a lot there. And I do a show called XR Podcast every week. Tomorrow we are going to host a show with Luke. So Luke is going to be there, and he's going to talk about fractal. So mathematics of fractal is fascinating, and he's going to talk about how fractal works. So tomorrow we are going to talk Luke about that. So he's also known as Fractal Gods. Yeah, I'm done.
Great. It was such a lovely session. I think the audience also much interactive. There are a couple of questions you have also answered. If there are any kind of question, do please feel free to reach out Avi Dwivedi on Facebook, Twitter, and obviously on over the LinkedIn as well. So thank you so much, Avi Dwivedi, for such an amazing session. I hope the valuable insights you have shared, it is definitely helpful for the community and the audience out here. Thank you so much.
Thank you, Ria. Thanks for inviting me, and thanks for organizing this GDG Kolkata. We are really thankful to you. And yeah, we are available for any kind of support in virtual reality, augmented reality. So do connect with us. Thank you.
Yes, yes, yes. Thank you. Thank you, everyone. I hope this session has some amazing insights that will help you in the coming days. We'll be back with some amazing session. Till then, you can follow us on Facebook, Twitter, follow us on Facebook, Twitter, and obviously on Instagram. Stay tuned. We'll be let you know when we'll be coming up next. Thank you, everyone.